Good day. All right, so today we're going to talk about seasons and seasonal patterns and how latitude is affected to seasons and the climate and how seasonal differences affect climate. Now, I will tell you that I saw a video a number of years ago of college graduates. They were in their robes and they had the hats on, and the person doing the video during the interview walked up to graduates and said, "What causes seasons?" And a very large percentage of them got the answer wrong. They did not know what causes seasons. And so hopefully, by the end of this, you will all get that question right. You'll be able to answer the question better than college graduates. All right, so what does cause seasons? Seasons is related to some of the things we've been talking about, the way energy is transferred on the Earth's surface, the way where the energy comes from the sun to the Earth, and the latitude. And remember, latitude is how far above or below the equator you are. And since the Earth is a sphere, when light is hitting further up, it's hitting at different angles. And so we'll talk about how light hitting the Earth at different angles impacts the climate and the season. All right, so just to review, the other types of heat transfer involve radiation, where energy just travels through space, convection, where energy is just moving through a fluid, and then energy transfer by touch, or conduction. So we want to remember that. Now we're going to be talking mostly about radiation in today's class. And then we also need to remember the Earth's energy budget, where energy is traveling from the sun through radiation. Some of that radiates back into, or reflects back into space. Some of it gets absorbed by clouds. And then once it gets absorbed by the clouds and the land, it can either radiate back out to space or through convection be carried to other parts of the atmosphere. All right, so one thing just wanted to take a look at, I have a graph, a temperature date graph of 3 different locations. We have Libreville, Gabor, which is right on the equator. And we can see that it's right around 30 degrees. Now, it doesn't say on here, but this is 30 degrees Celsius, which is about 95 degrees Fahrenheit. Here we have Rockville, which in the winter gets to be about 5 degrees. Not too cold. If you remember, I moved here from Milwaukee, and the coldest it gets in Milwaukee is probably a little bit farther down here. It gets down to negative 5, maybe even negative 10 degrees Celsius. And then in the hottest days, Rockville does get to be up here. The hottest days in Milwaukee get a little bit higher, but not very many days. We get, you do get high 90s, even 100-degree days, but we only get a few. So, like, my house didn't have air conditioning in Milwaukee because we only needed it for like 5 days out of the summer, but those 5 days were really hot. And then Rockville goes back down, and so why does it get warm and then cold? Well, if you look at here's January and February, November and December, so Rockville gets colder in the winter, that's obvious. And then we look at Burrow, Alaska. Burrow, Alaska is quite a bit colder. It's hot, its warmest days are about the same as Rockville's coldest days. So the hottest days in summer for Alaska is about our coldest days in Rockville. And why is it? It has to do with latitude. Really close to the equator, about halfway between the equator and the North Pole, and quite a bit closer to the North Pole. So when we talk about seasons and weather, it's all caused by the unequal heating of the Earth. And the Earth gets, it's really not as simple as just what latitude you are. There are all kinds of reasons why some areas get heated unequally. Surface types. We talk about land versus water. Land versus water gets heated differently. And then land covered in trees versus land that's just dirt. Dark versus light. Dark land versus light. Black. Parking lots that are covered in the asphalt versus a grass-covered field. In the same summer day, they can be right next to each other, but the grass-covered fields, it's going to be not nicer to walk on in your bare feet. Latitude, near equator versus far from the equator. Global and local winds are going to affect the global and local winds are affected by the unequal heating. We'll learn a little bit about that too. Winds are caused by unequal heating. Wind tends to blow from cool areas towards warm or hot areas. And in nearby landforms, we're gonna learn that lakes and oceans affect climate, and so does mountains. We're going to learn a little bit about how those things affect the average climate and temperature of particular areas. But let's stick with seasons and specifically latitude and longitude. Let's take a look at this. All right, so here we have the Earth is revolving around the sun. And I use the word revolving, not the word rotating. The word rotating has to do with the world spinning, which causes day and night. And as you can see, as the world goes around, if you look at this closely, you can see that the world is on a tilt, about a 23.5 degree tilt. And because the world's on a tilt, when the sunlight comes in, it's always lighting up half the world, but sometimes the bottom half, the southern half, gets more light. Sometimes the northern half gets more light. Sometimes it is even, where the northern and southern half get the same amount of light. And it all has to do with the way the Earth is tilted. I want to stress that. When those college students came out and we asked them the question, what causes seasons? If they would have said that the Earth is tilted, and because the Earth is tilted, there are some times when the Earth orbits around the sun, the northern half gets a little bit more sunlight, and so we have summer in the northern half and winter in the southern half. Sometimes it's even, and we have it's fall, and sometimes the southern half gets more, and we have winter in the northern half and summer in the southern half, and then it becomes even again, and we have spring. And we talk about the angle of the sunlight during different times of the year. The sunlight is coming in at different angles at different latitudes. Just looking at this, we can see that the most direct sun rays during end of May, or here we go, middle of June, is on 23.5 degrees north of the equator. I think we call that line, that line has a special name. We have the line above and below, we call them the Tropic of Cancer and the Tropic of Capricorn, and they're 23.5 degrees north, 23.5 degrees south, and the sunlight is most direct. And then when we go right around our spring, the most direct sun rays are right here on the equator. And then when we go to our winter, I'm actually going around the wrong way. We should be going around this way. So so if we go fall, it's right on the equator. And then winter, the most direct rays are south of the equator. And then it's back on the equator again. All right, so let's take a look at...
And there was no summer.
Temperature was so high you couldn't possibly form a complex molecule, and you need complex molecules for life.
But it wasn't just the 900-degree highs or the lack of air that kept Earth sterile. There was also a 100% chance of asteroid storms.
It was a shooting gallery, really. Enough of a shooting gallery that Earth's surface was getting pummeled.
But this only set the stage for the real cause of summer.
There's Earth minding its own business, with an axis spinning basically vertically in the solar system. A Mars-sized object careens off the side of the Earth.
Scientists call it the Big Whack. And guess what? This is the cosmic clash that created summer.
So this major impact in the early Earth birthed the moon, and likely also tipped Earth on its axis.
Okay, imagine the Earth is a really big rotisserie chicken.
This is what the Earth was like before the Big Whack, rotating around the sun a full orbit every year. As you can see, the middle of the chicken, its equator, is totally roasted, while the top and bottom, its poles, are still raw. Of course, after the Big Whack, the Earth's no longer on a straight axis. And the important thing to remember is that as it rotates around the sun, that axis is always pointing in the same direction. So different parts of the Earth warm at different rates at different points in the year. That's what gives us seasons and summer.
In the case of the Earth, it takes 365 days at this lopsided angle for each quarter to reach juicy perfection. This axial tilt made Earth a place where life could survive and diversify. Why is that? Because Earth finally had the secret ingredient for biodiversity, or the countless forms of life we know today. Seasons.
You know what seasons do? They put a stress on the environment. Anytime there's a stress on the environment, life forms have to figure out what they're going to do about it. It has diversified the kinds of life forms that it's possible to find on Earth.
Life forms that now include us. That is, unless the Big Whack that created our favorite season has a sequel in the works.
Which, of course, if it did, might knock Earth to another axial tilt. But, of course, we would just be completely vaporized.
But until that happens, just keep on enjoying how summer shaped life on Earth.
All right, so we talked about seasons are caused by the fact that the Earth is on the tilt. The Earth wasn't always on a tilt. Billions of years ago, the Earth was straight up and down, and then something knocked into it, causing it to tilt, and then we had seasons. And as Mr. Tyson said, the seasons potentially put enough variation on the temperatures and other things on the Earth that it helped life evolve the way it did. And if the Earth was never tilted, we never had seasons, life might not have evolved in the same way and might not have become as complex and interesting as it is now. We don't need to watch that. All right, so just to review. During the summer, the Earth is sort of tilted to the side. Now, this is going to be difficult because we're trying to show a three-dimensional system on a two-dimensional picture. But we could try. I try to show. We show the equator sort of tilted like this, and the North Pole tilted towards the sun. This is supposed to represent the Earth in June, when the Earth has orbited to the other side of the sun, where the North Pole is tilted away from the sun. Then we describe that as being winter. And so as the Earth goes around the sun, we got winter when the North Pole is tilted away from the sun. We got summer when the North Pole is tilted towards the sun. And I say summer because I mean summer in the northern hemisphere, winter in the northern hemisphere. Hopefully everyone understands that it's the opposite season in the southern hemisphere. And then in the spring and the fall, the Earth is still tilted, but it's sort of tilted off the side. It's not tilted towards the sun or away from the sun. So we got spring and fall. The path of the sun is different in different seasons. So if we take a look at that, we can see that when the sun rises, sun rises in the in the east and sets in the west, and this would be this is sort of May and mid-June, where the sun gets pretty high up into the sky at noon. But then in December, the highest the sun gets is just a little bit above the horizon. It doesn't get that far. And in fact, if we pick a different latitude, if I pick a latitude that's farther north, you can get to a point where the sun doesn't even come up above the horizon in December. And they don't have daytime in December at all. The sun doesn't come up. The sun doesn't come up on the North Pole until September, which is crazy for me to think of. That's at the North Pole. If you were in Alaska, you'd get day and night until right at the beginning of December. You'd stop having day and night, and at the end of December, it would go back to being day and night. But here, even here, you would only have, let's see, that's only a couple hours of daylight. Now, when we are at the equator, the longest days are in March and in September. So they have the longest days in March and September when you're on the equator. It's a little bit interesting. You could find some of these websites on your own. In fact, I think I might put them on the Edline, so you could play around with this yourself if you're at the computer. I think that might be fun for you to do. We just have 3 more slides. Okay, so when we talk about seasons, sometimes I'm going to use the words direct and indirect light. When we talk about being on the equator, the light hitting the Earth closer to a right angle versus when the light hits above the equator, it's hitting at an angle. We use the term direct and indirect to talk about that. And it gets warmer when light is hitting it directly. And so latitude definitely affects whether it's going to be getting direct or indirect light. When you're closer to the equator, you get more direct light and it's warmer. Now, one thing that college students said when they answered the question, what causes season, they said that Earth was closer to the sun in summer and farther from the sun in winter. Now, there's a couple reasons why that answer is wrong. First, if the northern hemisphere is having summer at the same time that the southern hemisphere is having winter, then the entire Earth, if summer is caused by the entire Earth being closer to the sun, then that would be false. Then the entire Earth would be in the same season. It turns out that July 3rd, we were 94, close to 95 million miles away from the sun, and January 3rd, we're 92 million miles away from the sun. So we're actually farther away from the sun in July during our summer. So hopefully that helps you understand what causes seasons. It's the tilt of the Earth and the way that the sunlight is hitting the Earth at different times of the year, and not because the Earth is closer or farther from the sun. Thank you.